Question 4 focuses on functions, and we are given two different types of functions. There is a parabola as well as a straight line, which are also known as linear functions. So we've been given a whole bunch of information pertaining to the sketch. So if I see numbers or any valuable information, I do want to put it on the sketch. So I see AB is 2 units long. So this line AB is 2 units long. And I also see that CD is 7 units long. So from C to D is 7 units long. The rest of the information tells us where our x-intercepts and y-intercepts are, as well as the turning point. And the first question says, show that P equals 3. P is sitting in the formula for h of x. Now this is all a little bit overwhelming, so to make it less overwhelming, I'm going to color code my graphs, and that's going to make my life like 10 times easier. And have a look at what a difference that makes. Right, so we've got to get P. Okay, that's going to be quite difficult. So we're actually going to have to work with the green graph, and let me show you step by step how this goes. Okay, so with a linear function, I can tell a couple of things from its standard form. So with this linear function, the number on the outside is the y-intercept. So I know what the y-intercept of this line is. It's b. So I know the coordinates of b are 0 and 5. Okay, so I chuck that on my graph. And then I know this line is 2 units long. So I just have to go 2 units down to get to A. So if I go 2 units down from 5, I'm going to get to 3. So now I know the coordinates of A are 0 and 3. And now there's one of two directions you can go. You can sub this coordinate into h of x, and it will give you P equals 3. Or if you know standard form for parabola, then this number at the end, the C value, or in this case the P value, represents the y-intercept, and I have the y-intercept, it's 3. So we can just conclude that P equals 3. Geez, I had to work very hard for 1 mark there. And the mark in this question, we don't get a mark for P equals 3 because they gave that to us. We only get a mark for showing how we got the coordinate of A, and we said 5 minus 2 to accomplish that. Okay, so we're getting to know these a little bit better. I'm going to replace P with 3 because that's what it actually is. And I like to have the equations of the graphs close by, so I don't have to keep going back to this information. I can kind of do it without looking at that now. Next up, they ask us to determine the coordinates of F. F is over here, and they told us earlier that it is the turning point of the parabola. So I'm going to use my turning point formula. Okay, to get the x value of my turning point, it's x equals negative b over 2a. A is the number in front of x squared, so it's minus 1. B is the number in front of x, so it's that 2. So let's pop those guys in this formula. And if we just work that out quickly, it gives us 1, because we get negative 2 over negative 2. And now we need to get the y value, so I'm going to take this x value and sub it into the equation of the parabola. So what that entails is you just change these x's to 1s, and then it's going to pop out an answer of 4. So now I know my turning point F has the coordinates of 1 and 4. And our 3 marks here will come from this guy, our substitution in there, our x value and our y value. Now, great news if you own a white calculator. So if you go to your white calculator and you go to mode 5 and 3, then you can type in the A, B and C value from your parabola. A is minus 1, B is 2, and C is 3. So you press equals. then you press equals again. Now there's your first x-intercept. So that 3 is C over here. If I press equals again, I get my other x-intercept. So that's this x-intercept over here. If I press equals again, it gives me the x value of my maximum, which is the x value of my turning point. And if I press equals again, it gives me the y value of my turning point. Brilliant little calculator trick. Next up, we are asked to determine the coordinates of C. C is over here. It's a very special point for the blue graph. It's an x-intercept. And to get an x-intercept, I'll make y equal to 0. So I'm going to do that quickly. Just remember h of x is a fancy placeholder for y, so I just change that to 0. Now I've got a quadratic equation on my hands. This negative is bothering me, so I'm going to divide every single term by -1 to get rid of it. Then we can just see a sign change happening with every term after that's done. Now I need to factorize this trinomial. So I'm going to look at the factors of 3 that will add or subtract to give me -2. 3 is a prime number, so it only has 2 factors, which are 3 and 1. Okay, and then I need to add or subtract those 2 factors to give me that -2 in the middle. So to get that -2, I can just say +1 minus 3, and that will give me the -2 in the middle. And from there we can make our 2 brackets, x plus 1 and x minus 3. And from there we equate each one to 0 and we get our 2 answers. So we get x equals -1 or x equals 3. Now I've got to decide which one of these actually belong to C, because the parabola has 2 x-intercepts. And we do it using its position on the Cartesian plane. I can see this one's on the left of the y-axis, which means it has to be a negative number. So that x-coordinate over there is the -1. This x-coordinate over here has to be the 3, so C will be 3 and 0. And the 3 marks here will be from equating to 0, the correct factors, as well as the correct answer. And now the last question from question 4 is our challenge round, 5 marks. We need to get the length of EC. EC is a perfectly vertical line, and how I know that is because they said EC is parallel to the y-axis in the original question. So that's a fancy way of saying EC is a perfectly vertical line. So it's very easy to get the length of a vertical line. You just take the y value on top minus the y value at the bottom. But that creates an obstacle. We don't have the y value on top. So now I want to get the coordinates of E to make this happen. So to get the coordinates of E, I need its x value. And its x value will take the same x value as C because that is a perfectly vertical line. And then once I've got the x value of 3, I just want to sub that in here to get the answer. But now there's another problem. I don't have m. So I need to go get m somehow. So it's going to be done through the gradient formula. We're going to get the gradient of this line, and that is the m. So to use the gradient formula, we need 2 points on the line. Currently, we've only got this point B. We've only got a half a point here, so that won't work. So I'm going to have to get this point D using the 7 units here. So if this is at x equals 3, I'll go 7 units over to get here, and D will be at 10 and 0. Okay, and then just be sure to leave behind some breadcrumbs, or basically show some working out to show how you got that value of D. Now I'm going to use the gradient formula with D and B to get this missing gradient value. Okay, so our gradient formula, y2 minus y1 over x2 minus x1, that is on your formula sheet. So I'm going to choose perhaps B to go in place of y2 and x1. So let's chuck him in. and then I'll put D's coordinate in y1 and x1's place. And then if you pop that in your calculator, it's just going to give you -1/2. And now we've got our missing gradient over there. It's -1/2. Okay, now I'm going to return back to the original mission. I'm going to put this 3 inside of this formula to get his y value. So I just replace x with 3. And then that goes straight in my calculator. Okay, so if we pop that in the calculator, it gives us 7/2. And then for the length of a vertical line, I take the top y value, which is on the green graph, 7/2, minus the bottom y value, which is on the blue graph, which is 0. And then that pops out my length to be 7/2 units, or if you want to see it as a decimal, it is 3.5 units. Okay, to close up this behemoth of a question, let's have a look where the marks are going. Showing how you got the x value of d gets you your first mark. Substitution into the gradient formula gets you your second mark. The value of the actual gradient gets you the third mark. The fourth mark comes from substituting 3 into your equation, and the last mark comes from the final answer, 7/2 units.